So I was originally scheduled to talk for about half an hour. I'm probably going to still do that, although I'll watch my time. I've got the unenviable job of trying to bring together this group of people and the subjects we're going to cover and set the stage, which I think is actually kind of impossible because I can't predict what everyone's going to talk about, and that's, I think, the beauty of the workshop is actually bringing together people from such diverse backgrounds, and so I'm not going to try to predict what's going to happen. I'm going to present what I think are some interesting problems and challenges that Java and other virtual environments are facing. It's going to be just that, in my opinion, and some of my colleagues in IBM. So let me get at it. So as a caveat, this is certainly not a comprehensive list of the challenges and opportunities, and also I'm a long-time compiler optimization guy, so if I slip into worrying about performance from time to time, as Andrew mentioned, that just comes natural, so forgive me for that. So where are we here?
I think you implied that you couldn't have performance. That was the point.
Yeah, exactly.
Well, there are appropriate times for performance. Yeah. So I think to characterize the sort of IBM environment that led up to trying to organize this, I think jointly we're rather excited, but at the same time a little bit nervous about kind of the divergent development of these VMs, or virtual execution environments, is the term that we're using now. I think it's excellent. I mean, the fact that we're able to innovate in language technology much more quickly than we were before, the fact that we're able to leverage tools that are out there in open source or commercially available is fantastic. On the other hand, our users, our customers are left with a menagerie of programming technologies that don't talk to each other. So that's kind of fundamentally the context that we're worried about. And of course, there's a number of other demands that are coming in on virtual environments that we're worried about as well. Performance certainly being one of them, and I'll touch on some others. The thing is, I think a lot of these environments actually add a lot of unique value. So there's reasons why they exist. There's a reason why Java came to be and why it has a community, and similarly for scripting languages, and similarly for the Microsoft CLR, which I think are kind of the main execution environments that we've got our eye on. And so I think that's all positive because they've built a lot of loyalty, and that's because they work really well by and large for those communities. And so I think that's all a positive. We want to encourage that. We want people to use the right tool for the right job. At the same time, we've got to let people build integrated systems over time. The other thing is that, of course, there's a number of things that are happening now or on the horizon in our programming model and our runtime technologies, things like model-driven execution models, like aspect-oriented programming and so on, that are really going to drive new requirements down into the runtime and into the programming model itself. So all this kind of together gets us a little bit anxious about our current environment of virtual execution environments. And so, we'd like to kind of take stock of where we are as an industry, where we are in the technology. And I'm anxious to hear about what your concerns are and what your vision is for the future in your specific communities and more generally. So let's move on. So who's here? I think Mike covered this on the big slide, but I think our objective here with the workshop, in terms of the attendees that we invited and why it was an invitational workshop, was to try to create a diverse mix of people, both researchers and practitioners, as well as from industry, from academia, and from open source projects. And I think we've succeeded pretty well in that. So thank you again for all of you for traveling here and for participating. I think it's going to be great. Right. So, I've already said this. I think that why you might be sitting here thinking, well, I've got nothing in common with the guy next to me, which is true in some cases. And I think the diversity that we've encouraged here is going to cause some interesting insights, whether you're living a little bit above the VM or way above the VM or underneath the VM or actually inside the VM. I think we're going to find new ways of talking to each other this week. As I say, if nothing else, we're going to be well fed and enjoy a few days in the woods here. So I hope you all enjoy yourself here. Take advantage of the facilities for the time that we've left you. In terms of free time, it's going to be a packed agenda. Which was a bit of a trade-off, to be honest. We wanted to get great representation. On the other hand, we're left with relatively little amount of time to speak, each of us. So As Mike pointed out, please be respectful of everyone as they're speaking. Make sure they get, at least 15 minutes to say what they want to say before we start the discussion. But realistically, we're going to be 25 minutes of talk and 5 minutes of question and answer at the end. Okay, so let me get into what I think are some challenges and opportunities. A few definitions, because I always like to start with definitions. In a crowd this diverse, there's going to be at least 35 opinions about what a virtual execution environment is. So I'm going to define what I think it is. So the word virtual to me really means that the specification of the behavior of the environment is independent of any one operating system or hardware platform. Okay, so that's one definition. I also require that any program running under a virtual execution environment can be inspected, manipulated by itself or by other programs. Okay, and it does that by availability of rich type instructional information in the environment. And also that the virtual execution environment acts as a container, and the container can provide security, can provide safety, can provide isolation, and so on. So what do we get out of all this? And so this is kind of taking stock of everything that we've gotten from virtual execution environments, and I think it's, to be honest, we've reaped tremendous gains from VM technology, from things like Java, from the CLR, from Smalltalk, from Lisp, from the whole history of virtual execution environments. So kind of taking stock, having this portable, well-specified platform gives people assurances about the behavior of their program. So that's I think one of the key benefits for this level of virtualization. And as I pointed out there, it's really what we've done is we've factored the runtime into language-dependent and system-dependent pieces. And that's one of the key benefits and why we've got this portability story. We've got, because of the availability of the ability of the execution environment to act as a container and to control the behavior of the program, we actually have new security and safety guarantees that we wouldn't necessarily have on native operating systems. And I think notably, and probably the reason that we've seen tremendous growth in Java specifically, is we've got huge productivity gains from things like the assured safety, from garbage collection, automated memory management, from the variety of tools that have been built up, which I think there's still tremendous opportunity to build on the tool collection we have, but the sophisticated debugging tools, incremental compilation, analysis tools, refactoring tools, and so on, that have built up because there's a leverage point for these tool manufacturers when you have a virtual execution environment that hosts on multiple operating systems. There's new kind of incentive to build sophisticated tooling. But of course you've got runtimes that offer all sorts of information that you wouldn't necessarily have, or at least would have to root around and have specific code to figure out previously. And then, of course, for a lot of our middleware, we've got automated support for distribution and persistence, which I think has been really key to the development, certainly of WebSphere and of J2E. And my last point, because I always have to talk about performance, is high levels of performance are possible. I think actually the history, as we've seen it, is performance has always been kind of a drag. Or at least the performance weenies have always said that virtual execution environments or VMs are just too slow. We have to natively compile everything. And that has been true historically. But I think we've made tremendous progress with dynamic compilation, tremendous progress with garbage collection to the point where, it can handle massive heap storage, it can handle fragmentation, it can handle, basically giving you throughput and reasonable pause time concurrently. So that doesn't say that there isn't a lot of room for improvement there, but I think we're kind of reached a point where performance is satisfactory, that it's not at the top of everybody's mind anymore about VMs. However, I think there's new opportunities now. Right? We haven't really touched on all of the opportunities of compiling concurrently with the execution of the program, of understanding what is the workload running right now on this program and how can I specialize the code to that workload. The ability to speculate and do optimizations that would otherwise be, of course, incorrect. You're working on partial information, but you know that you can back out if you've got a problem. Of course, there's lots of examples of these optimizations, but they're really in the minority, in my experience. What we've done is we've actually kind of taken all of our history of compilation technology and made it work dynamically. And so that's excellent, but I think we're just at the beginning of exploiting the real opportunities of compiling concurrently with the program. just taking a developer's point of view, what do they get from virtual execution environments versus native execution environments? Clearly back to the portability story, they spend a lot less time authoring and debugging and system-specific code, and that's a big deal. Okay, so they can actually leverage their effort and spend less time doing that and more time looking at their code. That leads, I think, to fewer bugs and failures in their case with Java, for instance. Support and really the infrastructure from logic, really middleware value proposition, if you like, is that middleware infrastructure managed through a container can be managed separately from your logic. That's all really enabled through the portability of execution environments. So what does that mean to developers? It means that they don't have to worry about all that stuff, and they can focus their attention on getting their logic right most of the time. I think that that's not a whole story either. I think that they spend far too much time worrying about debugging some of those layers, the performance of some of those layers than they ought to. But I think that's sort of a statement of the point in time where we are. From an ISV perspective, sort of a special type of developer that makes a business out of driving their software to maximum number of users and platforms, they can leverage their efforts much more effectively. So they basically get a better return on investment on developer efforts. And the last